Today's topic is integration by parts. This is the formula that we are going to use. And u is x squared unless ln x is not in the question. If ln x is there, u is always ln x. Example 1. X cosine x dx. If x is there, u is x, so cosine x dx is going to be dv. U is x, du dx is going to be 1, derivative of x is 1, so du is equal to dx. If dv is cos x dx, we have to find y, so we have to find v. So take the integration of dv, it is going to be v, and so we have to take the integration of cosine dx. So v is going to be integration of cosine x is sine x. So here x cosine x dx is going to be uv, where u is x, v is sine x, minus v, which is sine x du, and du is dx. So integration is going to be x sine x minus cosine x. Integration of sine x is cosine x, is negative cosine x, plus c. So the answer is x sine x plus cosine x plus c. Always you have to put c, the integration constant. Now, let's do another example. Here, the example 2 is for double by parts. So, again, let's write the example here. X squared e to the power of x dx. Here, this is u, x squared is u, dv is e to the power of x dx. Now, if u is x squared, du over dx is going to be derivative of x squared, which is 2x. And here, dv is equal to e to the power of x dx. To be able to find v, we have to integrate both sides. And integration of dv is v e to the power of, v is equal to e to the power of x, because integration of e to the power of x is e to the power of x. Now, what was the rule? uv minus v du. So, x squared e to the power of x dx is going to be u times v minus, here we have to write that du is equal to 2x dx. Do not forget to write du in terms of x. When we come here, this is uv minus, it is going to v times du. What is v? V is e to the power of x, and du is 2x dx. Let's put this in order. X squared plus times e to the power of x minus, take these two outside of the integration because it's just a constant to multiply, and take x there, e to the power of x dx. And that integration here needs another by parts. So that's why we call it double by parts. Call this one I, and you need to call it I because of iteration. Say that I is equal to x e to the power of x dx. Again, you have to say that this is u and this is dv. U is x, du over dx is equal to 1, derivative of x is 1, du is equal to dx. So come here, dv is equal to e to the power of x dx. To obtain v, we have to integrate dv. So we have to integrate the right hand side as well. So v is equal to e to the power of x. Here the answer is going to be, for I, it has to be uv, u is x, v is e to the power of x, minus v du. V is e to the power of x, and du is dx. And when we do this integration, x to e times e to the power of x minus integration of e to the power of x is itself e to the power of x. So we know I here, I is x e to the power of x minus e to the power of x. So here in place of I, we can substitute its equivalent. The answer is going to be x squared e to the power of x minus 2 times x e to the power of x minus ex. And at the end, we have to put plus c, the integration constant. This is a good example for double by parts. Let's revise the solution once more. When you have such a question, such an integration, you see that there is no substitution and we cannot solve it by partial fractions. The only way to do it is by parts. And what did we say? U is either x or x squared. And remember, in this question, in this integral here, we don't have ln x. Ln x is totally different case. So, u is x squared. Take derivative to be able to find du, because in the formula we have du there. Du over dx is 2x, so du becomes 2x times dx. Here, to obtain v, we have dv there. And how do we obtain v from dv? By taking the integral. So we have to integrate both sides. The integration of the left hand side is dv, so it becomes v. Integration of e to the power of dx becomes ex. And apply that formula. What is the formula? U is x squared. What is the expression for v? V is e to the power of x minus integration of ex, which is v, times du. Du is 2x dx. I did a simple manipulation here. I take 2 outside of the integration and change the places of x and ex. So when you check this one, this also needs another by partial, integration by partial. So we call it I, you have to call it I always. That I do not comes from integration, it comes from iteration. because we need to iterate the whole process once more. We need to repeat it. So here we call x u, and that becomes dv. We did the same thing here. Obtain du is equal to dx, and if dv is equal to e to the power of dx, v becomes e to the power of x. So u, which is x, v, which is e to the power of x, minus integration of v du. V is e to the power of x and du is dx. So we did a simple integration there for e to the power of x, and integration of e to the power of x is itself. So we obtain that I is equal to x times e to the power of x minus ex, and take it there, substitute the expression for I there. So x squared e to the power of x minus 2 in the brackets. I substitute the expression for I and put the integration constant there, and this is called double by parts. Now I am going to erase the board and do an example with lnx and see what is going on with lnx. This is going to be example 3 for integration by parts. Now we have a clean board here, and let's write example 3 for integration by parts. Say that x squared ln x dx. Now you have to be very careful here. You have to be very careful here, because in the question we have x squared, which can be u, and we have ln x here. Be careful. While using by parts, if in the integration, if we have ln x, you have to call it u. That's the case. Very, very important. In the question, if in the integration, if we are going to use by parts, and if we have ln x is always u. That is very, very, very important. So I am going to change the places here, put ln x there, then x squared dx. So u is ln x. That's the only case when x squared is not u, when ln x is in the integration. So dv, this is u, now that becomes dv. dv is x squared dx. So take derivative of u with respect to x to obtain u, because this is the formula that we are going to apply for integration by parts. uv minus du, integration of du. Du over dx becomes, what is the derivative of ln x? You have to remember it, and you have the table of integration and table of differentiated for special functions in your booklet, and derivative of ln x is 1 over x. So du becomes 1 over x dx. And let's come here, we need to obtain v. How? By integrating dv. We are going to integrate the left hand side, also we need to integrate the right hand side. Integration of dv is always v. Let's integrate x squared, basic integration here, add 1 to the power and divide by the power. And let's apply the rule here. ln x squared dx is going to be uv, here u is ln x, v is x cubed over 3 minus v, which is x cubed over 3 times du, which is 1 over x dx. Now, Here, I need to do a simple simplification there and change the places of these two functions, these two expressions to have a better view. X cubed over 3 ln x. Now let's do a quite simple simplification there. X cubed divided by x is x squared, and I'm going to take 1 over 3 outside of the integration to have a simpler integration there. Remember, x cubed divided by x is x squared, and I took 1 over 3 outside of the integration. So x cubed over 3 ln x minus 1 over 3. What is the integration of x squared? X cubed over 3. And at the end, we have to put a plus c there, which is the integration constant. So x cubed over 3 ln x minus x cubed over 9 plus c is the integration, is the solution for x squared ln x. Remember, the most important thing is here is, if in the question, in the integration, if we have ln x, what do we have to do? We have to say that ln x is u. That's the most important thing, that we have to be very careful in this integration. The rest is easy. Now, after doing example 3, I am going to solve another example here. One more time, we have a clean board. Say that, for example, let's solve x cosine 3x plus 4 dx. Here we are going to use by parts, and straightforward we are going to call x u. So that expression here involving cosine is going to be dv. So u is x. Du over dx becomes 1. Du is equal to dx. Now we have to obtain v. To be able to obtain v, we know that dv is equal to cosine 3x plus 4 dx. Do the integration for left hand side, also for the right hand side here. Integration of dv is v. What is integration of cosine 3x plus 4? You have to know it by heart. It is 1 over 3 sine 3x plus 4. So apply uv v du to the question, because that's the rule for by parts. U is x, v is 1 over 3 sine 3x plus 4. This is 3, have a proper 3 there. Minus v 1 over 3 sine 3x plus 4 dx. Let's put them in an order. And what is the integration of sine? It is minus cosine, negative cosine. We have 3 there, and we have 1 over 3 there. So it is going to be 1 over 3. The integration of sine is negative cos, the expression there. So let's have a proper answer. Minus minus becomes plus. 1 over 3 becomes 1 over 9. Cosine 3x plus 4 plus c. Now, and this was example 4, I think. Yes. Now, example 5. A very classic one. What is integration of ln x dx? Now, we have to be careful. If in the question we have ln x, we have to call it u. U is ln x. So dv is going to be dx. U is ln x. dv is equal to dx. du over dx is 1 over x. Derivative of ln x is 1 over x. So du is equal to 1 over x dx. Here, to be able to find v, do the integration for dv. So we have to do the integration for dx as well. What is integration of dv? It is v. What is integration of dx? It is x. So uv minus v du is the rule for integration by parts. U is ln x, v is x. You cannot multiply these two. It is a silly mistake to multiply that x by x, because that x belongs to ln. Do not multiply them. So v is x, du is 1 over x dx. These two x cancel each other. Let's put them in an order there. Take x in front of ln x, not to mix them, not to multiply them, not to have a silly mistake there. X cancel. We have 1 there. What is integration of 1? It is x. At the end we have to put c. That is whole thing for integration by parts. Let's give some exercises and finish integration by parts by giving some exercises. Exercises. Here we have to be careful because we have double by parts. You need to do double by parts there. Be careful to obtain the answer. And you have to be careful there because ln x is always u. Here be careful. We have ln x. When we have ln x, u is always ln x. And that's the end of integration by parts. Tomorrow we are going to do, in the next lesson, we are going to do integration for areas and volumes. We are going to find areas and volumes by using integration for Cartesian equations and for parametric equations. That's the end of the lesson. See you next time.